So for today, we're gonna be solving some problems with regards to the physical properties of soil in here. So in the left panel, I have the formulas here, and for the problem, I have it in here in the right part. So let's take this first example. So for a moist soil sample, the following are given. So the total volume is 1.2 cubic meters. Then total mass is 2,350 kilograms. The moisture content is 8.6 percent, and the specific gravity is 2.71. So we have to determine the moist density, dry density, void ratio, porosity, degree of saturation, and the volume of water in the sample. So how are we going to do this? Okay. First of all, we are given the, sulat ko na lang muna siya para hindi tayo malito later on. So I have here the given. Okay. Para mas mabilis ko siya makita. So the total of volume of the sample is 1.2 m cubed. Take note that is for the moist, okay? Because in the initial condition it was stated in the problem that it is a moist soil sample. So that is the total volume of the in situ soil sample. So that volume contains voids pa, okay? Next, we have the mass, the total mass, which is 2,350 kilograms. And then the moisture content is 0.086, and the specific gravity is 2.71 there. So the first item or the first question being asked is for the moist density. Okay, so it is an you have to take note, guys, that the um the unit weight and density are interchangeable units, okay? So if you're going to divide the unit weight by the acceleration due to gravity, that will transform the unit weight into the density, okay? So we have the moist density, okay? So ganyan. Normally, I'll write it here moist na lang para hindi kayo malito. Pero normally, um, sinusulat yan na ganito na lang. So if you're going to see a gamma na walang subscript or a rho na walang subscript, those are already under the moist condition or the original condition of the soil. Okay. So what is our formula for the moist? Okay. So the formula for the moist, similar to your unit weight, that would be mass over volume because that's the basic formula for your density. So you just substitute the values we have here. So that's 2,350 divided by 1.2. Okay, so your moist density now is, let me just open my calculator, divided by 1.2, and that is 1958.33. Okay. Next thing, the next question being asked is the dry density. Okay, so I'm going to put it here. Okay, raw dry. Okay, so if you're going to scan for formulas there, we can actually use the dry unit weight formula. Okay, that is this one, formula number 7, the second one. So as I mentioned, that gamma and the raw are actually interchangeable units. So we can write this as the moist all over 1 plus water content because we already have the water content. So let's substitute. That is now equal to, oh, I forgot. Let me kilogram per m cubed. Don't forget the units. So that is now equal to 1958.33 divided by 1 plus 0.086. So that is your moisture content, okay, the 0.086. So let me just calculate this one using my calculator. Okay, so the answer here is 1803.25 kilograms per cubic meter. Okay, so that is now your dry density. Okay, so do not be confused, guys. Lagi kong inuulit that gamma and the raw are actually interchangeable. Okay, so lahat ng formula nyo for the gamma, palitan nyo lang yung mga gamma dyan ng density or ng density symbol. Yun na mismo yung formula nyo for the density. Okay. So, palitan nyo lang yung mga symbol dyan. Okay, manipulate nyo lang siya. Next thing that we're going to calculate is the void ratio. Okay, so the void ratio in here. Okay, so marami tayong given. Okay, marami tayong given for this particular. But I think we can use yung here sa Roman numeral number 6, number 2 formula for the dry unit weight because we already have the raw dry. Okay, so I'm gonna put it here. Raw dry is equal to GS because we have the GS. Then, palitan natin yun ng raw ng water all over 1 plus E. Okay, so this is now equal to 1803.25, which is equal to, what is our GS? That's 2.71. Okay, and then multiplied by running water. Let's use 1000, guys. Okay, all over 1 plus E. Okay, from here on, we can now get our E. So let me just do that. 25 must be equal to 71 multiplied by 1000 over. So your E is 0.50. Okay, so that is your void ratio. Next thing that you're gonna get is the porosity. Okay, so porosity. So kung meron ka ng void ratio, you can actually compute for the porosity N. Okay, so what's the formula for your porosity? That is just equal to E over 1 plus E. Okay, so your porosity now is equal to um, 0.50 divided by 1 plus 0.50. Okay, so your N now is equal to 0.33. There you go. Okay. Next thing that we're going to calculate is the degree of saturation, or the S. Okay, so let's see it here. We can actually use formula number 4, okay, in Roman numeral number 6, and then formula number 4, that is SE is equal to water content multiplied by the specific gravity, because we are already given the void ratio, the water content, and the specific gravity. Okay, so your S multiplied by 0.50 is equal to 0.086, which is the moisture content, multiplied by 2.71, which is your specific gravity. So your S now is equal to, wait, that is 0.47. Okay, or this is also equal to 47%. Okay. Next thing, we have to compute the volume of water in the soil sample. So in this case, guys, we all know that okay, let me just write it here. In the soil. Okay. So we're going to calculate the volume of water. Okay, we can actually use the void ratio because the void ratio is actually the volume of voids all over the total volume. So tingin tayo ng magagamit nating formula in here. Okay, so I think we can use the porosity and the saturation formula. okay, to get for the volume of water because we already have the S there, that's 47%. And then, makukuha natin yung volume of voids, okay, na magagamit natin for the saturation formula, okay. Makukuha natin yung volume of voids from the porosity, okay. So I'm gonna write it here, N is equal to volume of voids all over the volume of soil, and your saturation now is equal to volume of water all over the volume of voids. Okay, so your porosity is equal to 0.33, which is equal to volume of voids, which is unknown, all over. We have the total volume, guys. Okay, so yung total volume na sinasabi dyan, that's the in situ volume. So that's 1.2 cubic meters. Okay, so that gives you now a volume of 0.40. Okay. Sabihin lang natin 0.40. Okay. So what is now your saturation? Okay. Your saturation is at 0.47, which is equal to volume of water all over the volume of voids, which is 0.40. Okay. And your volume of water now is 0.19. And this is in cube. Okay. So that is your first example. Okay, so far it's the formula that you're going to have problem with kasi depende sa given. Kasi sobrang dami ng formula and it depends on the given kung ano yung gagamitin mong formula. Okay, so that is your example number one. Okay, and you may access this file in the physical properties of soil part 2. Yung PDF file is already there. So you can just review that later on. Okay, so next proceed to the next problem. Okay, so we have it here. The following data are given for a soil. So porosity is 0.4, the specific gravity is 2.68, and the water content is 12%. So determine the mass of the water to be added to 10 cubic meters of soil for full saturation. So in this question, guys, we are already given two conditions. Okay, so the first condition is we have the initial, okay, condition of the soil, which is yung meron siyang porosity and water content. So that pertains, kung meron yung water content and may porosity, it means that is already your moist soil or the in situ soil sample. Then we have yung full saturation. When we say full saturation, guys, the volume of voids is equal to the volume of water. Kasi sa sobrang dami ng tubig nung sample, wala nang room for air. Okay, so in terms of volume, we are considering the volume of air. Okay, kabilang yung volume of air sa volume of voids. Okay, so kapag ang soil is 100% saturated, okay, or the saturation is equal to 1, ang nangyayari is walang volume of air na kasama. It's just the volume of water and then the volume of soil in the sample. Okay? So wala tayong air na kasama. Okay. So what we can do here is to solve for the density. Okay, for the density of the soil, the initial density of the soil, and then the saturated density of the soil. Okay, so when we say the initial density of the soil, that is the moist density. Okay, and then we'll solve as well for the saturated density of the soil. And then let's take the difference between that. Pwede na natin makuha yung change in density. Okay, change in density, and from that change in density, pwede natin makuha yung volume of or yung mass of water to be added to that 10 cubic meter of soil para ma-saturate siya. Okay. So, tingin tayo ng formula na pwede natin gamitin. Okay. So, we are given the porosity, water content, and GS. So, dapat dito tayo sa Roman numeral number 7. So, gagamutin natin yung moist unit weight na formula and the saturated unit weight. Pero we're going to transform the unit weight into density para mas mabilis. Okay? So, lagay natin dito, yung first, okay, Let, mag-assume muna ako, let delta rho equals the change in the density of the soil. Okay. So that is, ito yung isolve natin, the delta P. Okay, that will be one of the requirement before natin makuha yung mass of soil. Okay, so let's compute for the moist density, and that is equal to GS rho ng water multiplied by 1 minus N multiplied by 1 plus the water content. Okay, so this now is equal to the GS is 2.68 multiplied by 1000 multiplied by 1 minus 0.4 multiplied by 1.12. Diniretso ko na guys kasi 1 plus 0.12 yan. So let me just calculate this one. 1 minus 0.4 multiplied by 1.12. So this is now equal to 1,800.96 kilograms per cubic meter. Okay, and this pertains to your moist density. Okay, how about the saturated density? Kasi kailangan natin yung saturated density because sabi nga sa problem, we have to achieve daw saturation, full saturation. Okay, so I'm gonna write it here. Okay, and that is now equal to 1 minus n multiplied by GS plus n and then rho ng water. Okay, so your raw sat now is equal to 1 minus, what is our porosity? That is 0.4. Okay, multiplied by 2.68 plus 0.4 multiplied by 1,000. Okay, so your raw sat now is, wait lang, just calculate it. Okay, it's 2008 kilograms per cubic meter. Okay, so we're gonna solve now for the delta P, and that is just the difference between the raw sat and the raw moist. Okay, so I'm gonna get now delta raw is equal to raw sat minus raw, which is equal to 2,800, 2008 rather, minus, I think that's 1,800.96. So your delta raw now is equal to 207.04 kilograms per cubic meter. Okay, so we now have the raw. Okay, so using this raw, we can now compute for the mass of the soil. Okay, so ayan siya. Okay, so sulat ko dito 207.04, which is equal to the mass daw of water to be added all over what is the volume of the soil, that is 10 cubic meters. Okay, so I'm gonna put it here 10. Okay, so what is now the mass of the water or the mass of water to be added? So let me just so that is, I think, 2070.4 kilograms. Okay, so that is now your um that is now the mass of the water to be added to the 10 kilogram 10 cubic meter rather soil. Okay, so that is your problem number 2. Okay, so let's move on naman dito. Okay, so ito naman gawin natin. For a given sandy soil, Emax is 0.75, Emin is 0.4, the specific gravity is 2.68. In the field, the soil is compacted to a moist density 112 pounds per cubic feet at a moisture content of 12%. Determine the relative density of compaction. Okay. So, dati ko na sinulat yung formula dito. dr is equal to, or the relative density is equal to Emax minus E all over Emax minus Emin. Okay. So, ano ang nawawala sa atin? Okay, sa given, okay, hindi na ibigay yung void ratio, yung initial void ratio. Okay. So, how are we going to do that or get that? We just need to use itong given. Okay, binigyan tayo ng raw moist and ng water content. So, pwede natin gamitin yung formula for the moist density. Okay, and that is equal to, ayan, GS raw ng water times 1 plus water content all over 1 plus E. Okay. So, given na sa atin yung density ng tubig. Okay. So, in GS natin is 2.68. And then, what is the raw of water in terms of pound? That is 62.4, guys. Okay. So, huwag yung kalimutan, multiplied by yung water content. So, that's 1.12. Diniretso ko na, guys, ha? Hindi ko na siya in-add. Okay? All over 1 plus E. Okay, so what is now the value of the E? Okay, let's calculate 112 multiplied by 1. X must be equal to 2.68 multiplied by 62.4, 1.12. So I think the E here is 0.67. Okay. So, meron tayong E, we can now compute for the DR. Okay. So, yung DR natin, Emax natin is 0.75 minus 0.67 all over Emax minus Emin, 0.75 minus Emin is 0.4. And what is now the relative density? I think it's 0.23. Okay, so or that is 23%. Okay. So let's make some let's describe the soil kasi when you get the density kasi meron tayong description here. Okay. So it is here is the qualitative description kapag merong relative density. So kung meron tayong relative density, okay, ito yung range niya. So magfo-fall yung ating soil under the loose, okay? So we can conclude that this soil is a loose soil kasi it's 23%. So, yung 23 is between 15 to 50. Okay? So, that is now your uh, example number 3. Okay? Madali lang naman yung example number 3. Next thing that we're going to solve now is ito. Okay? So, example number 4 for this section or this topic. Okay, sabi dito, shrinkage limit test. Okay, so punta na tayo dun sa shrinkage limit. Ito. Okay, so we have the initial volume there, and then we have the final volume, which is 15.9. The initial mass, 44, and the final mass is 30.1. Determine the shrinkage limit of the soil. So, very basic lang siya, direct substitution sa formula. Okay, so I'm gonna write it here, the formula now, which is equal to M1 minus M2 all over M2 multiplied by 100 minus initial velocity tuloy. Initial volume minus final volume. Ayan. All over M2 multiplied by raw ng water multiplied by 100. Ayan. So, direct substitute na natin siya. Shrinkage limit is now equal to, what is M1 or the initial mass? That is 24.6 minus 15.9 all over 15.9 times 100 minus initial volume, that's 44, minus 30.1 all over M2, this 15.9 times 1. Kasi 1 grams per cubic centimeter because the units there in the given are expressed in terms of grams and cm. Okay, so multiplied by 100. Okay, and what is now your shrinkage limit? Okay, so let me just calculate it. 24.6 minus 15.9 all over 15.9 times 100 minus 44 minus 30.1 all over 15.9 multiplied by 100. Okay, wait. Tama ba? Okay. Nag-negative siya sa akin. Ayun, negative siya sa akin. Why is it negative? Wait. Wait. Nag-negative yung shrinkage limit sa akin. So, wait lang. Let me just, ulitin ko lang yung, okay. Napagbaliktad ko siya, guys. Sorry about that. Okay. So, this one, napabaliktad ko kasi ang binigay pala is yung ganon. Okay, so, na-confused na din ako, guys. So, ililipat ko pala to because hindi dapat siya dyan. Napagbaliktad ko. Okay. So, dapat ito pala dito, dyan, tapos ito, dito. Ayan. So, tama na ba? 44 initial mass, final mass 30.1. Okay. And then I'm gonna change this pala. So this should be 30.1 there. So 44 minus 30.1 over 30.1 times 100 minus zero point 0.6 minus 15.9 all over 30.1 multiplied by 100. Okay, so your shrinkage limit now is 17.28%. Okay, and this is in terms of percent lagi, guys, because this is an Atterberg limit, and Atterberg limits are actually moisture contents. Okay, so that is your shrinkage limit, and that will be the examples for physical properties of soil. So it's really just a matter of how you're going to memorize the formula and how you're going to manipulate the formula. Okay, so if you do have questions, please do message me in Telegram. That would be all. Thank you. Bye bye.